Alright, so we've been given a second order homogeneous differential equation. These are relatively simple. Well, I say that. We have to first assume that the solution is of the form e to the rx, and there's some theorems which show that this is the complete set of results. But let's just assume that for now. You should know this. And now we can figure out what the derivatives would be using a simple chain rule. With these, we can sub these back into the original equation, and we can form the auxiliary equation after we realize that e to the rx can never be 0. So I'll show you what that means. We'll substitute this set of equations into this differential equation we're given to get r squared minus 7r plus 10, and taking out this e to the rx as a factor. So now we form our auxiliary equation because this is never equal to 0. So therefore this r squared minus 7r plus 10 must be equal to 0. Let's write aux equation. As you can see, this is a simple quadratic, can just be factorized as r minus 5, r minus 2. So we get r is equal to 2 or 5, which gives us our two solutions for y as either e to the 2x or e to the 5x. Okay, so now to form our general solution for y, we're going to get some coefficient e to the 2x plus b e to the 5x. Reason this works is because these essentially function independently, such as if we substituted e to the 2x into this equation, we would get 0. And similarly, if we substituted e to the 5x into this equation, we'd get 0. We can add a coefficient in front of them because adding a coefficient will just keep all these derivatives with the coefficient in front, and then you just divide by that coefficient since the right hand side is 0. And you can see we could substitute both of these in simultaneously and we'd still get the same. We'd still get 0 because 0 plus 0 is equal to 0, if that made sense. So here's our general solution for y. Now we need to use these initial conditions. So we have when x equals 0, we have y dash or dy by dx is equal to 1, and d squared y over dx squared is equal to 8. There we go. So let's differentiate our initial general solution. We have y dash is equal to 2a e to 2x plus 5b e to the 5x, and we'll call these conditions I and ii. So substituting in I, we get our first equation. We're going to get 2a plus 5b is equal to 1. When we put 0 in for x over here, the e to the x just becomes 1. And so we get this. Now substituting in ii, we get our second equation. We're going to get, we need to figure out the second derivative of our general solution. So we're going to get 4a e to the 2x plus 25b e to the 5x. There we go. And now we can substitute in this second condition. So we're going to get 4a plus 25b is equal to 8. Okay, now we have a set of simultaneous equations with these two. Pretty simple. Let's just multiply number 1 by 2 throughout to obtain 4a plus 10b equals 2. Then we will subtract these to eliminate a. 15b is equal to 6. So b is equal to 2 over 5. Then we can substitute this right back into number 1. 2a plus 5 times 2 over 5 plus 2 equals 1. So a must be equal to minus a half. And therefore we have our final solution, minus 1/2 e to 2x plus 2/5 e to the 5x. And there it is. Thanks for watching, and I hope to see you guys in a future tutorial. Bye.